launched a balloon as a kid, or maybe just seen them randomly flying through the air? When they're filled with helium, they move up pretty quickly. So what happens to them? Where do they go? And why do they tell us not to launch balloons like that anymore? I'll give you a clue. This is what's left of the balloon. No matter what, any balloon that's let go into the atmosphere will eventually end up like this, which is really, really terrible for the environment and is one of the reasons why they tell us not to launch balloons anymore. But why does it explode? What's going on? It didn't touch anything. So what happened? Do you have a bicycle pump like this one laying around your home somewhere? Well, you can do an experiment that demonstrates the same phenomenon as the balloon, but in kind of a reverse order. So take your thumb, put it over the nozzle of the bicycle pump, lift the handle and give it a good push. You'll notice the handle pushes back and even bounces back upward as you try to squeeze whatever's air is inside that pump. If you push really fast, it creates a back pressure. So I'm trying to squeeze this air, and the air doesn't like that and it pushes back. So we're seeing the behavior of a gas here that makes you wonder, what's going on? Why does it push back? So for the next example, it's the same phenomena, but in a slightly different situation, and it's kind of in reverse of what we saw before with the balloon. So we have this is a syringe, and you might have seen one of these either at a doctor's office, or maybe you got one after you got your wisdom teeth taken out. They're pretty common for just they use them to flush out various things or add specific amounts of a fluid or gas to something. In this case, we're going to get 15 cc's or 15 milliliters of gas inside the tube, and there's a little opening right there that allows the gas to get in there. So now we have a tube of gas. And I'm going to take my thumb and I'm going to plug the other end with the end that the gas can go in and out. I'm going to plug that with my thumb, and then I'm going to give this a little push, and watch what happens when I push on that. As soon as I let go, it actually pushes that piston or that syringe plunger back up, and that's doing it all by itself. Okay, so what's going on here? Why would that happen? How is it possible that this is able to just push back up by itself? If I don't have my thumb on there and I push down, that's it. Nothing happens. So there's a lot to be thinking about here. What have I done by taking 15 milliliters or 15 cc's of a gas and squeezing it down to almost 5 before it becomes a little bit hard to move? And then it just comes back up all by itself. So what's going on here? Now that you've seen a couple different phenomena, take some time and really think about each one. What's happening? What's going on? Can you come up with an explanation? Pause the video if you have to. Talk to your classmates or your teacher. If you can't come up with a full explanation, think of some clarifying questions you might be able to ask. Now take a look at one last phenomena that occurred in a chemistry class that I taught not too long ago. Inside the soda bottle is some aluminum foil and some hydrochloric acid. The soda bottle's been sealed. A single replacement reaction begins to take place, which produces excessive amounts of hydrogen gas as a product. How is this related to some of the other phenomena we've already seen? What do you think might occur? Make some predictions, talk about it with a classmate, and then watch to see what happens.
Drink it. There it goes. See it?
Yeah. All right, now get it away.
All right. We're going away, bro.
It works. Is it loud?
Oh no, yeah, it's pretty loud.
Holy!
I hope the phenomena in this video have given you a lot to think about and set you up to learn a whole lot more in class. If you have questions, feel free to reach out to me or your teacher. See you soon, and thanks for watching.